Good morning. We are going to explain the algorithms we have to manage memory. To replace page in the memory, we have 4 algorithms. The first one is FIFO, first input and first output. We are going to explain. In this case, we have the page reference in this and 4 frames. Frame 1, frame 2, frame 3, frame 4. This algorithm works like this. In this case, the first page 6 put in this place in the first frame, 0 in the second frame, 1 in the third frame. Here the algorithms are the same because the page 6 has already loaded. In this case 2 place here in the fourth frame and continue the same because page 6 is already loaded, 1 is already loaded, 0 is already loaded. 3, in this case 3 had to there is no space in the memory, so that reason we had to replace the oldest page has been loaded. In this case is 6. This is the first page has been loaded in the memory. It replaces. Continue like this. Here there is a new 7th page. Is not space in the memory, has to be replaced. In this case, replace the page 0 in the frame 2 because it's the oldest page has loaded in the memory, and continue like this. Now we're going to see this working this algorithm in a code. The language is Python. In this we have a function it's called algorithm FIFO. We have 3 variables, yes, to work. This is a loop to go through in entire reference, page reference. You have a conditional to know if there is a space to add the page in the memory or need to be replaced the oldest page for a new page. Okay, we're going to run the code. In this case we have the last one is the memory has page 2, page 7, 4, 0. Look at the table, it's like the same, 2, 7, 4, 0. In this case we have name faults. Let's continue with the second algorithm. The second algorithm is called least recent use. Least recent use. Okay, and there is a page reference, 2 frames, and this is a fault. Let's begin. And the first page is 6, put in the first frame, 0 put in the second frame, 1 in the third frame. 6 is not change made because this page has already loaded. So let's continue with here 2 in the last one frame, put here, and continue like this until here because the page 6 has already ready, page 1 has already loaded, and 0 has already loaded. Here we have a new page 3, and there is no place in the memory, has to be replaced this page. And this algorithm checks which page has been least recently used. If we check 0, page 1, page 6, 2 is the page has to be changed for 3 for new page. Here 0 is the page in the memory, 2 is a new page, are the same. Check the algorithm check which page has been least recently used. 0, 3, 0, 1, 6. 6 is the page that has least recently used. So this page has to be replaced for a new page. In this case, page 2. This algorithm works like this, and now we are going to test in the code Python. Okay. Let's go to here. Okay. Here we have the algorithm. It's called algorithm LRU. Has two parameters, page reference and frames. Page reference like this, and frames, for this case, word. We had variables like this, like before, like that. Here, memory, page files, use tracker. Use tracker is a variable to know which page has been least recently used. There is a loop for page to go through interrupt, page reference, conditionals, if, else. These conditionals is to check if there is a space in memory. If not, this change, it replaces the page for the last recent used page here. And this have function print to show the page in the memory. Let's run. Continue. The last one has 2307 pages. We're going to compare it with the table. We have 2307. 2307 are the same. Let's continue with the next algorithm. It's called LFU, least frequency use. How the algorithm works. In this case, we have the same reference page. We had 4 frames. So the first page put in the first frame, 0 in the second, and 1 page in the third. Yes. In this case, in this page 6, there is no change made because the page has already loaded in the memory. And the last one, the 2 page, is put in the last 1 frame. Continue like this until here. In this case, all the frames has a count. Count store the times that the page has been called. Here. When there is a new page and there is no memory to put in the frames, so check which page has the lowest count. Yes, in this case the lowest count has page 2, the count number 1. It has a number 1. In this case, the count number 2, this count number 3. So that reason this page has been replaced for a new place. Continue like this, 0, no change made, and 2, there is a new page. So which the algorithm checks which page has the count with the less number. In this case, the page 3 has only 1. The count has only 1 number. So it needs to be replaced with a new page. It works like this. Now we are going to check in the code. We have a function. It calls algorithm LFU. It has 2 parameters, and page reference and frames. Page reference and frames word. We have 3 variables: memory, that is a list to put a page on the memory; page faults to count how many faults are in the algorithm; and page frequency, in this case to know how many times the page has been called. There is a loop to interact with the page reference, and there is a conditional to know if there is a space in the memory or need to be replaced the new for the new page in the oldest page. There is a function number, and there is a count to increase the whole page, and there is a function to show the page in the memory and to show how many faults are in the algorithm. Let's run the algorithm. We have here, yes, the page in the memories. The last one is 60073. In this case, we have 12 faults. Let's check the table. We have the same faults, and this is the last. They have 6, big 6, big 0, 7, and 3 are the same with the code. Okay, thank you very much.